Welcome back. We'll be starting Chapter 6. Chapter 6 is one of the most important chapters, and a lot of people get confused on this chapter because now we are learning how to do compartmentalization, basically divide and conquer. And historically, we have called functions different names, and you probably will hear a couple of different terms in this chapter as well. We used to call them subprograms, procedures, subroutines, functions, methods, and modules. So there are different names being we have used in historically for these functions. So in this chapter, we'll learn how to create. In fact, we have been using predefined functions. Predefined functions are functions given to us, and we use them from different libraries. Today, we'll learn how to create our own functions. We call them user-defined functions. Now, some functions they return a value, some functions do not return a value. So I'll be showing you both of those. And one of the function prototypes, something we need to tell the compiler that I intend to create a function so the compiler is not confused. And I'll show you a function which does not return anything. It's called void function. And the functions are basically can pass arguments or parameters with values, or they can pass by references. This actually confuses some people, so once we get there, I'll explain that one as well. And finally, the local variables versus global variables, and what are the static variables. So we'll be discussing all these concepts in this chapter. And also, the main function becomes a driver function, and it calls many other functions. And there's a concept called overloading function. Overloading means that all the functions, they have the same names, but slightly different signature. Signature is basically the function header. And this will make sense probably at the end of the chapter, and I'll explain that to you as well. All right, so like I stated, the functions historically have different names. We have called them modules, we have called them mini programs, subroutines, subprograms, and methods in object-oriented programming languages, or even simply just call them functions. The purpose of the function is to break the larger system, let's say tens of thousands of lines of code, into smaller interacting functions, smaller interacting pieces. And that's the whole idea, that you can break the complicated program into manageable pieces. That's the whole idea. And if you don't do that, imagine if you're working in a team of 10, 20 people in your team, how you're going to divide your roles and responsibilities if you're writing the code. So each individual will be responsible for a certain number of functions. And these functions can pass arguments. We call them messages or parameters. And in C++, we have used some of the pre-existing functions. We call them predefined functions. In project number 4, when we used a square root function, for example, and also in the previous projects, chapter 3, we learned about set W, set precision functions, and I showed you the demonstration of POW, power function, many other function. So function typically has a name. That's the name of the function. At the time of the creation of that function, you identify a reasonable name. And the function also might have 0 or 1 or 2 arguments. Like in this case, we have 2 arguments. Arguments are basically messages we are passing to that function. So that particular function receives those arguments, and then it does something with those arguments or those messages. And the purpose of the function is to make your program more manageable. So these are predefined mathematical functions. For these functions, if you remember, we used a CMath library. So predefined functions are organized into separate libraries, like we have CMath, we have fstream, we have string, we have iostream, and many libraries. And if you are working in Java, you will find similar kind of setup as well. You include those libraries when you need them. You don't need to include the libraries unnecessarily. If you're not going to work on math related to computation, you don't have to include that library. All right. So the sum functions, they return a value. And some functions do not return a value. Those are called void functions. They do not return. When you say value or type, it means no data will be returned back to you. So the void functions do not have a keyword called return. Return means I'm going to return something back to you so you can capture it. Imagine if you had a square root function, which you saw in the previous slide, it returns something back to you so you can capture that value. Now, some functions are designed like I stated, void, and some are value returning functions. The value returning functions always have a keyword return. So whenever you see a keyword return inside the body of the function, it means it's a value returning function. And in C++, you can return one piece of data at a time. You cannot return five things at the same time in a traditional way, but uh, there's a way around it, and I'll explain that one to you as well. All right, to use these functions, you must include the appropriate header file, like the library name. You have to know the name of the function. How do you call that function if you do not know the name of the function? And if that function is designed to take an argument, you must pass that argument. Otherwise, it's a mismatch. And the type of data you pass should also match. For example, square root function is designed to take a decimal value or whole number or something of that sort. But if you try to pass a character or a string, that will be a mismatch. And then function, if it's returned something back to you, you must capture it. Imagine if something is being returned to you and you do not do something, you do not do anything with that returned value, it will be wasted. So when it's returned back to you, you can immediately display it. Number one, you can actually store it in another variable. Number two, you can actually put it in an equation and process it. Number three, or you can pass it on to another function. So remember, there are five options. Do nothing about it. You can actually display it. You can store it. You can process it, or you can pass it on to another function. So, can use the value returned by value returning function by saving it, storing it, printing it. The book actually shows you only two or three different options. I gave you five different options. Okay. So heading of the function, it's the first line. This is the header of the function. This tells me a lot about a function. This tells me this function is a value returning function. How do I know? Because it doesn't say void. Whenever it says void, it means that function doesn't return anything. And I can also tell the name of the function is called ABS or absolute. I can also tell this function takes one argument, and the argument type is integer. So I have to pass an integral data or whole number to this function. For example, if I pass -5 to this function probably is going to remove the positive or negative sign. It just returns the whole number back to you. And in case of this function, it takes two arguments. So we need to know how to call that function by the function name and what arguments to be passed. And we also need to know what is the purpose of that function. That function is going to return something back to me or not. All right. So we will be writing our own function in the next slide or so. Let's take a look at this one here. So this one is the return type, integer here. This is the name of the function. This is the parameter or argument. In this case, there's only one argument. This is the body of the function. How do I know? The curly brace opens here, curly brace closes here. So inside the function, this is the body of the function. All right. And because this function was value returning function, because int says tells me it's a value returning function, it must have a return keyword. So I'm returning this number back to you. The number you sent me, I'm checking if it's less than 0. If it's negative, I'm going to make it positive. If the number was negative, make it positive and return it back to you, because that's the nature of the function. This function basically removes the negative sign. Okay, how do you call that function? You can simply use the name of the function and any arguments in there. Okay, and we'll be doing all those things. Here's a function call. Let's say the function is called ABS. In parentheses, you can send -7 and it will return something back to you. And that is called the function call. And the return statement, function return its value via the return statement. So when it's returned something back to you, like I stated, you have 5 options. You can capture it, process it, display it, and so on and so forth. Okay, that's the return statement. Return is a keyword. When return statement executes, the function immediately terminates. Controls goes back to the caller. If you're calling from the main, the control shifts back to the main function. When the return statement executes in the function main, the program terminates completely because return basically exits that particular function. Here is another function. This function basically checks between two numbers which one is a larger number. I can tell by looking at the function, this function returns a double data type. I can check it has two parameters or arguments. One is called x and y, the second is y. Both are double data type. Name of the function is larger. Then this is a called local variable. Maximum is a local variable. Maximum doesn't exist outside. In fact, the outside world, other functions do not know if this particular variable exists. It only lives and dies in that function. When you leave that function, the function larger, the maximum actually dies. Its scopes ends right there. So all you're doing is checking the logic here. If x is greater than y, maximum is x, otherwise maximum is y, and return the maximum. And you have seen such programs in Excel or other places as well. The function prototype means this is the header of the function. When you run the function, compiler needs to know this function exists in your application, in your system. By doing so, you copy the header of the function and end with a semicolon. So function heading without the body of the function, basically it's telling or alerting the compiler, don't panic, you're going to find this function somewhere. And if you don't do that, compiler will get confused and compiler doesn't know what to do when the function is called. All right. So value returning function, in this case, we call a function called secret and takes an argument and checks some kind of condition, returns something back to us. And it's telling us this particular case, this might be better. This option will be better because it is possible that this condition might not be true, then return the original value instead of the other one. And it compares, and I'll show you all sorts of different value returning function in my demonstration. So the flow of the compilation and execution always begins at the first statement in the function main. Other functions are executed only when they're called. If the function body exists in your program, but if you never make a call, those functions are never called. They are never executed. So function prototype appears before the main function, on the top of the main function. And the reason is compiler can correctly translate a function call. Otherwise, compiler will be confused. Function call transfers control to the first statement in the body of that particular function. When the end of the function is executed, control is passed back to the previous function or previous location. All right. The void functions are functions which do not return anything to us. And they do some internal computation, they do some kind of internal processing, but they have nothing else to return back to us. And I'll be showing you some void functions as well. Like we indicated earlier, in the void function, you do not include a return statement. That will be a syntax error, and the compiler will not be happy. So formal parameters are optional. A call to void function is a standalone statement. Void function's definition, this void function, you have passing some arguments, and then you run the some statements there. And it's just showing you different types, and I'll be showing you my own. Now, most of the times, When you pass an argument or parameter to a function, it passes the copy of that particular value, which means if I'm sitting in a main function and I'm passing, let's say, variable x or variable number, and what it does from the main, it makes a copy of that number and passes you the copy of the number to the other function. Now, sometimes you do not want to do that. You want both functions to look at the same memory location for the same value. That kind of passing is called a uh, reference parameter or reference argument. So in a formal parameter that receives the location or memory address of the corresponding actual parameter. What it means, it looks very complicated, but it means when you create a variable in the memory, the main function and the other functions, they are pointing in the same direction where the existing or original location was created. So both of them are going to work on the same location of the memory, which has a lot of benefits because then you are not creating multiple copies of the same variable. You're using the original copy for both of them. And also, in that way, you can pass or return multiple pieces of data. If you remember, I had mentioned earlier, you can only return one piece of data when the function is called. In case of references, you can return multiple pieces of data. So if the formal parameter is value parameter, the value of the corresponding actual parameter is copied into it, and the copy and it's explaining what I just explained it to you. And this is also explaining exactly, once I go to my demonstration, this will make more sense. And reference parameters are useful in three situations: returning more than one value, like I stated. Remember, in a value returning function, you cannot return more than one value in C++. But with the reference parameters, you can return two, three, four values. Because how do you return them? You basically are pointing in the same memory location. If the second function modifies those values, they are instantaneously available in the original or main function. So again, change the actual parameter. When passing the address would save memory and space and time. So it is actually efficient. At the same time, reference parameters are dangerous because you basically lose the original value. And because other function has the ability to overwrite, so you use the original value in case of reference parameters. Value and reference parameters and memory allocation, I already mentioned that to you. You basically lose the original value. It's going in more detail, and I'll explain that to you as well. And when you read the chapter, it's going to make a little bit more sense. It's telling us can also use reference parameters in a value returning function, not recommended. Whenever you use a reference parameter, it is better to use a void function, not a value returning function. That's what it's saying. It's not recommended here. By definition, a value returning function returns a single value via return statement. In case of reference, we can return multiple pieces of data. So there's no need to have value returning function. And that's what it's saying. If the function needs to return more than one value, change it to void function and use reference parameter. The scope of an identifier or variable is when the program or the function can access it. Local variables, which I indicated when I showed you the max variable, it lives and die only in that block or in that particular function. Global variables are my pet peeve. Global variables should not be declared. They are declared outside of any function, and they are available to any one of those functions. Very highly discouraged. Don't use global variables. You can use global constants, but not the global variables. They're very dangerous. So global identifiers, it goes in more detail. I will discourage you not to use global variables. I'll show you how they're used, and I'll talk about that when I go to the demonstration. And you can actually have nested block identifier accessible from declaration to end. And it's just going the scope of that particular variable when the particular block ends. And it's just talking about the global variables still over here. And let me see, there's something else I need to show you. It's just talking about global variables. It's saying global constants have no side effects. I completely agree with that one. And global variables, if you use global variables in project number, any project, I'm gonna not going to accept it. Global variables are completely from legacy programming from 60s, 70s, and 80s. We should discourage them. We should not use global variables. Now, the variables which are declared inside the function, memory is allocated at block entry. When you enter that particular function, memory is allocated and deallocated at the when you exit that function. By default, variables declared within a block are automatic variables. You don't have to say auto, but you could. And the static variables, when you leave that function, it still remembers the previous value of that particular variable. So memory remains allocated as long as the program is not terminated. If you're still in the same program, it remembers the value of that particular static variable. And with a static variable, you have to say static. And for auto variable, automatic variable, you can say auto, but you don't have to. Okay. And this is how you can declare static variables. Static, int, some kind of variable name. Okay. The driver is a program which basically drives the entire system. So typically your main function becomes a driver function and all other functions are called from the driver function. It's more like a supervisor calling all other functionalities. Now, sometimes you want to create overloaded functions. For example, you have a function doing similar things but taking different types of arguments. Then you can have the same name for the function but different types of arguments. And I'll demonstrate that one to you. For example, if you want to create square for integers versus square for doubles, then you can use the same function name. And that's what it's saying. The two functions said to be have different formal parameters, but they have the same name. So overloaded function must have different function signatures. Signature is the function header. And it's just basically mentioning that one further. The last thing it mentions here is the default parameters. Default parameters, sometimes you want to give initial values to those variables, such as 1 or 0 or something of that sort. So if the outside function call is not providing you the proper values, at least you have default values. And that's the end of the chapter. So now what we'll do, we will go to our demonstration. Let me open that one up and let me see if I have this one open. All right, let me try again. All right, I think you can see my screen now. And I would like to demonstrate a function. So here is I'm going to write a function right here. I'm going to call this one void function. This function doesn't return anything back to me. This function doesn't take any argument. It has, you can see inside the parentheses, 0 arguments, and the function is not returning anything. All we do is we just simply display, um, let's say, hello from another function, just to see if this function is being called successfully or not. Then I want to make the function call. I want to say display. This is how the function is called. Remember, main is like a driver function, so it's just calling that display function. Now, what we are missing is we are missing the prototype. And most of the compilers, they will give you the error message that I don't recognize this display. Let me run and see if this error message is shown here. And here it is. It tells me display was not declared in this scope. So compiler says, I have no clue what display is. And you can say, well, function is right there. Why don't you call it? The compiler doesn't know. So what we do, we copy the header of the function, or we call it signature of the function. We post it above the main and put the semicolon. Leave the body of the function in place, just the signature of the function. Now when I run my code, the function is called successfully. So function basically shifted. When the function call happened, it shifted from here and it executed the body of the function. And because this function was not designed to return anything, nothing was returned, as well as the function did not take any arguments. All right. Now let's write another function called square function. Square function. Now this function, we're gonna pass an argument to this function. Passed argument 2. All right, so I'm gonna write the square function here, and this function is gonna return something back to me, because the purpose of this function is to make whatever value I pass you, make it square of that one. And the name of the function is called square. Takes an argument of integer type. Let's call that number. And here is the body of the function right there. All we are doing is, I'm going to just show you the simpler version first, then I'll actually tweak it a little bit. So all I'm returning is number times number. All right, and semicolon. Now, why do I have this return keyword? Because this function is a value returning function. It must return something back to us. That's the rule. So that's why we have a keyword return. What exactly I'm returning? I'm returning number times number. Whatever you sent me, let's say you sent me 2, 2 will be captured in this variable. 2 times 2 is 4, so I'm returning 4 as an integer. Now remember, I indicated to you that if you don't do anything when the value is being returned, it will be wasted. But before I do that, I need to copy this header of the function, put it above the main function, put a semicolon at the end as a prototype. All right, let's run the code. When I run the code, and that 4 is not being displayed anywhere. The reason is the value 4 was returned, but I didn't do anything with it. Okay, let me see if I can display it. You can display simply like that. Let's put ENDL at the end, so we have a cleaner look. All right, let's run the code again. This time I'm anticipating 4, and 4 is being displayed. All right, as we expected. Now, what if I want to capture that value? I don't want to display it. I'm going to use it for some other purpose. All right, let's actually declare another local variable number and initialize it to 0. So when this is being returned, I'm going to say number equals square. So now you're capturing that value. All right. And then once it's captured, I want to display that number. I want to display that number just to ensure the data actually was collected successfully. All right. So I want you to pay attention to something here, guys. See this local number variable? It is localized. This number is only known to the main function. On the other hand, this number here is a local variable to square function. These two things are not the same. This has its own memory location. This has its own memory location. Just want to highlight that one. Okay. And I'm going to show you, in fact, if you are interested, I can show you the memory locations as well. But let's just run the code first. When I run the code, this time I get the same exact results, but this time I captured the result first, then I displayed it. Let me also show you the memory location of num in the main function. So I'll say num in main, so we can differentiate it. And if I put the ampersand sign num, which will show me the memory address, and if I copy this one here and put this same statement here, this time I say in a square function, you'll see they will have two different memory locations. All right, let's test it. And here it is. Num in main is completely different memory location. Num in square is completely different memory location. All they're pretty close, but they are not the same. This one is BC, this one is 9C. So literally on this cloud environment, their memory locations are highlighted. They're pretty close to each other, but they are not the same memory locations. Okay, just remember that one, because in a few minutes we'll be passing as a reference. Right now, this is called pass by value. And that's what I wanted to highlight. They are different values in each one of those functions because they are local variables. While I'm here, I'll also show you something I really, really, really dislike. It's called global variable. Global variable is this. This is a global variable. Now, this is something I don't even like to demonstrate it because this is something I dislike. This num can be modified by any functions. This function main can modify it, can access it. This square function can access and modify it. It means this is insecure. So the only way you want to declare something global is a constant. So let's say global, and you say value of pi, and you can say double, for example, and 3.54, for example, or 3.5, whatever. And typically, the constants as a tradition, as a protocol, it's not required, but you typically do in the uppercase. That's the only global thing we should declare. Nothing else. Nothing else outside. No names, no logos, no balances. Nothing should be global. Global is something outside of the functions. All right. So I showed you a function which doesn't return anything, and I showed you the function which returns an integer. Now I'm going to create another function called cube function. And this cube function, oh, before I do the cube function, let me also show you the overloading as well. So overloading is you have the same function name, and let's actually change the signature a little bit. But this time, function name is the same, but inside here, you have same function name, but inside the argument is different. Or maybe the return type is different. So, but in reality, it does exactly the same thing. So I'm going to copy this one here, returns the same value, and I'm going to copy this one, put it above the main function, put the semicolon as a prototype. Let me see if I can display this value of square. Oh, one more thing. How do I know if I call square function like this, which square function is going to call? Well, at the time of the execution, the compiler says, okay, I'm going to call a function which has the ability to take a double data type, which is this one versus this one. This one can only take the whole numbers. This one has the ability to take the double data type. So let's check it out. And here I'm going to leave a message here, and I'll call this one double just to differentiate, and just to differentiate, and then value will be returned back to us. Actually, let's put a ENDL so there's no confusion about that one. So now we will be displaying the square, and we are expecting that it will display the double. Let's run the code. And here it is. It says double and 6.254. So it did not call this function. It called the appropriate function because compiler is pretty smart. Compiler said, oh, you have a double data type. I'm going to call the appropriate function. And this concept is called overloading, function overloading, that you can have the same function name, but the argument or the type number of arguments or the signatures are different. Okay. Let me add one more function. And in that function, I'm going to call this function here cube function, cube. And cube function also takes an argument. And cube function returns number times number. Because it's a cube, it's going to return three, it's going to multiply three times. Now, I want you to pay attention here, guys. When I call the square function, let's say I pass 2 and it returns 4 back to me. And I did mention during the PowerPoint slideshow that you can actually pass the value of which is being returned from function to another function. How do I do that? You can simply do this way. So when this particular function, let me comment out this part here to avoid any confusion. So when I pass this 2, so hopefully this function will return 4 back to me. Then I immediately pass the 4 to the cube function. So it will capture 4 here, 4 times 4 times 4. And it will return that particular value, and the value will be displayed right there. All right, let's test it out. And it doesn't like it because I forgot to include this one in the prototype area. Let's drop it there. Let's read on the code again. And this time you can see 64 is being returned or displayed. Why did I get 64? Because 4 times 4 is 16, 16 times 4 is 64. So this is a function within a function. Okay, so you can have many, many complexities. You can also, when this particular value is being returned, you can also do computation right there. So let's say you can say, well, I want to divide this by 2, just for the heck of it, just for the sake of it. So now we are expecting 64 divided by 2 will be 32. Let's test it out. And we got 32. So you can play with all these different options when you're dealing with these numbers. Okay. Now for the sake of next project, uh, I just want to demonstrate a couple of things. I will not be showing you entire project because by now you should be able to solve any kind of problems. But let's say there's a zip code. Uh, let's say we declare a variable called zip code. Initially it is 0. And I want to ask the user, please enter a zip code. This is for sake of project number 6, I believe. Please enter your zip code. We can say 5-digit zip code. So zip code will be sent by the user or given by the user. And then we capture that zip code right here. Here's my zip. Oops. Yeah, in my case, I say zip only. And once I capture it, the good practice is you always want to test it. You always want to test it. So in that way, you can test and test because programming requires a lot of testing. So when I run my code, it's going to ask for a zip code. I say my zip code is 90808 and it displays that successfully. Now in project number 6, we have to separate each digit. I need to separate this 8, this 0, this 8, and so on and so forth. So I need to declare multiple variables here. Let's call them, again, to save some time, I'm going to just call them everything in one line. I recommend you use separate lines for your project, D4, D5, and let's just stop into these 5 of these variables. I want to separate the digit 5, which is the last digit. So how do I do that? Digit 5 equals to zip code. That's where the logic is going to come for project number 6. So there's a special operator, which is the modulus operator. We probably didn't use it earlier in the project. So the modulus operator gives you the remainder. So if you have a perfect divisor, then of course you will get zero remainder. But if you have not perfect divisor and modulus operator looks like this, it looks like a percentage symbol. It's not a percentage in programming languages. And if I do modulus 10, let's see what happens. And I want to display D5. Okay. So let's say my zip code is 95014. And if I do divide by 10, looks like 4 might be the remainder. So let's test it out. And if I run my code and I say 95014, and it gives me the last digit here. So we successfully parsed the fifth digit. Now, how do I do the fourth digit? Digit 4 equals zip and percentage sign here, or the modulus operator. And if I do 100, let's see what happens with digit 4. And let's change that to D4. It's not going to give me exactly what I'm looking for. And let's call this one digit 5. So we can separate each one of these. Let's call this one digit 4. Digit 4. All right, let's actually run it and then we'll go back and try to fix it. So here it is, 95014, and I get digit 4 successfully and digit 5 successfully. Digit 4 I did not get successfully because I did the division by 100 and the remainder is 14. That's not what I wanted. I wanted 1 separately. All right, so now if you put that in parentheses, and again, this is where your logic is going to come. And if you divide by 10, for example, let's see what happens. When you divide by 10, and I have the same 95014 zip code, this time when I hit enter, I was able to just grab the 1. So this is how you can separate each one of these digits. Once these digits have been separated, you can easily add them together in a variable. So this will help you to complete project number 6. I'll show you one more thing. In project number 6, um, it also says, well, you have to show the barcode for each digit of your zip code. So uh, again, let me show you, and I'm going to share my screen for you. And if you go to this zip code exercise, it has 2 pages in it. I was showing the first part of it. Let me switch this location. And I showed you this part here. I showed you, let me switch this one here. So notice that the digit 4 should be 01001. It should be shown like this here. So 01001. How do I do the demonstration for that one? Let me go back here and let me share my screen with you. All right. So I want to show 01001. I do recommend, and that's not very hard, I would do recommend you use separate functions because this is the chapter for each function. All these things should be done in separate functions. If you do not do in separate functions, you will not get the credit for this exercise. At least 4 or 5 functions must be used. So, but I'm trying to show you everything in one place so you can easily understand. If I want to convert my digit number 5 into, I know digit number 5 is 4, 01001, I can simply say digit, if d5 equals 4. Again, I'm oversimplifying it. When you're writing the code for the entire system, for the entire assignment, then you have to come up with a better mechanism. I'm just trying to show you how to convert a number into barcode. Then you will show, and the 0 is basically your colon. You can simply put a colon there. And 1 is basically your pipe symbol, which is right above the enter key. And here it is. There you go. And let me run the code again. And when I run my code again, I put 95014, and there it is. 4 is converted into that format. And because in your case, you'll have 5 digits and there's something called correction digit in the project, you should be able to develop and show me something as shown in the second page of the assignment. All right. I'm going to let you complete that one. Hopefully by this time, you should be able to convert your digits into barcode. All right. I'll see you guys in the next chapter.